Alright, hopefully you've had a chance to start on your problem of the day for Unit 6, Day 3. A couple things before I even get going is I want to highlight a couple of important points. First of all, we're given that we have point P, which is 13 centimeters from the center of the circle. And I want to make sure that you understand that that has to be outside of the circle because we're told that the radius of the circle is 5 centimeters. Okay, so obviously point P lies in the exterior of this circle O. So it's a circle named Circle O. And so as I said in the beginning of all of these problems, what we need to do is we need to draw a picture. Okay, and so to draw a picture to start, I'm going to do my best to draw a circle. So there's a circle. And we're told that we're given a point P 13 centimeters from the center of the circle. So I'm going to do my best right here to draw point P. There's P. And then it says PA and PB are two different tangent lines going to the circle. So I know then that that means that there has to be a point right here. We'll call this point A, and I'll call this here point B. Okay, and I guess I should have labeled the center of my circle O. And I know that these are tangent lines. So that means that that connects here and that connects here. Those intersect the circle one time. And then I'm going to draw on a couple other lines. I know that the distance from O to P, I was given that that is 13 centimeters. So that's an important point to understand. And then I'm also told that the radius of this circle is 5 centimeters. So I can also connect in these two lines here. And I know that each of these radii is 5 centimeters. Okay, so that would be a very good picture to help ourselves get started right away. And so from that point, we have to understand a couple properties of tangent lines and radii. Anytime that a tangent line intersects with a radius, we know that that makes a 90-degree angle. So I know that I can draw in a 90-degree angle here, 90-degree angle there. Okay, two 90-degree angles. And from here, that takes care of angle PAO. So I know that the measure of angle PAO right up here, I know that that's equal to 90 degrees. So that one's already taken care of for me. So then, as we continue to move on to our next problem, it says, find the measure of angle APO. So I need to find the measure of angle APO. APO is this angle, or excuse me, is this little angle right down here. Okay? And so fortunately for us, I have a triangle that I can use to help me try and find that length. I'm going to look at this triangle right here. And I know that it's a right triangle. And since it's a right triangle, I can use some right triangle trig in order to help me set up to try and find that angle APO. So to do that, I'm going to draw a triangle just off to the side so I can see what kind of trig ratio I want to use. So I have my right triangle drawn, and what I'm going to do now is I'm going to try and set up a trig ratio to solve for angle APO. So right now what I'm dealing with is I know that I have the opposite leg from where I'm looking. So the opposite leg would be this one right here, and I also have the hypotenuse. And I know that sine deals with the opposite and the hypotenuse. So I'm going to say that the sine of theta, the angle I don't know, is equal to the opposite leg over the hypotenuse. And so that's the trig ratio that I'm going to set up to try and solve. So just like we practiced the other day in class, if I have an angle that I need to solve for in my trig ratio, I know I'm going to have to take an inverse trig function. So in this case, I'm going to have to take the inverse of sine in order to get theta by itself. Then when I type that in my calculator, the inverse sine of 5 over 13, it's going to give me that theta is equal to 22.62 degrees. And that's going to be my measure of angle APO. So I got that part done. The measure of angle APO is 22.62. Alright, and lastly I need to find the measure of arc AB. Here's the measure of arc AB. This is what I'm looking for. I'm trying to find this distance right here. Okay, sorry for the sloppy drawing, but that's the distance I'm going for. Now it's really hard to find that if I don't know any other parts of the arc of the circle. But what I do know is that is also equal to this central angle right here, since the central angle is equal to its minor arc. So what I'm going to try and do is I'm going to try and solve for half of this angle right here. Solving for half of that angle from one of these triangles, I can then double my answer, and then that's going to give me the measure of arc AB. So I'm going to set up my work and I'll show you what I'm doing. Alright, so what we got here, I tried to solve for the measure of arc AB, and what I did is I took 180 degrees, which is the measure of the interior angles of a triangle, and I subtracted the angle that I knew, that's this one right here. And then I subtracted the 90-degree angle up top, and that left me with 67.38. 67.38 is just this little half part of this central angle. So in order then to get the measure of the entire angle, I multiply that by 2. And 2 times 67.38 degrees is 134.76. So this central angle is 134.76, which is going to be equal in measure to its minor arc. Therefore, the measure of arc AB, or this minor arc, is also 134.76 degrees. Now from this point, let's scroll on down and we'll talk about what we're going to do in today's lesson. Here's the gist of today's lesson. What we're going to be dealing with is we're going to be dealing with a chord. Okay, and so here's a chord. And we're going to be given kind of 3 different scenarios. If you know that you have a chord that goes through the circle, and you also know that you have a perpendicular bisector of that chord. So this is perpendicular. And you also know that that perpendicular bisector goes through the center of the chord, then we may assume any of the 3 if we are given 2 of those. So again, if we're told that the line, this line right here goes through the center of the circle, and we know that this is also the midpoint of the chord, or this is a 90-degree angle. If we have 2 of those 3 things highlighted down here, then we're able to say that this is a 90-degree angle, that is the midpoint, and then this goes through the center of the circle. And I'll show you how we're going to set that up. This is just kind of background information. So scroll ahead to problem number 4. So as with all of these problems, what you want to do is draw a picture. Okay, so problem number 4 says the properties of chords you explored in this investigation combined with trig methods allow you to find measures of various angles. It says suppose that a given circle has a radius of 6 inches. Okay, so that's important. Then it also says what is the length of a chord that has a central angle of 115 degrees. So there's a lot moving on right there, but first of all, draw a picture, draw a circle. That's the first key to all of these problems. So that says, what is the length of a chord that has a central angle of 115? Well, in order to do that, I'm going to have to draw in a chord. Okay, so here's my circle. I'm just going to draw in a random chord. And then I'm also told that in this circle, the radius is 6 inches. A convenient radius to draw is something like this. And I'm actually going to draw 2 radii so I get this big triangle right now. Alright, so I've drawn in my given information. And so what we're supposed to find is we're supposed to find the length of this chord. And right now, just with our given information, it's not too useful. So the whole premise of all of these problems that you're going to work on is make a right triangle. And that's what those theorems that we had listed up above kind of come into play with. So if you're given this picture, we can always draw this picture right here. Anytime we're given one of these chord problems, we can drop in a perpendicular bisector to that chord, making this a 90-degree angle, and thus that means that this distance is going to be the same length as that distance. So in essence, if you can find one of the lengths of this triangle, okay, so this part down here, that's going to be equivalent to this one as well. So if I can solve for one of these lengths, that's going to allow me to try and find the entire length because I can simply double it since it's the midpoint. Okay, so in all these problems, draw in the chord, we can draw in the perpendicular bisector and label the triangle with our given information. We were told that this arc right here is 115 degrees. How did I know that that arc is 115? Well, they told us that the central angle is also to 115 degrees. So I have those 2 pieces of information. And my task is I want to try and find this length right here, the length of the chord. But in order to do that, what I'm actually going to try and find is I'm actually going to try and find this length here by itself. And then to try and find that length, I'm just going to use some right triangle trig. I'll double it, and then I should come up with my answer. So what I've done now is I split this triangle right here. I just drew it a little bit bigger off to the side. Since this entire central angle is 115, I'd cut that into 2 equal pieces, making this angle right up here 57.5. I knew the radius was 6, and this length x is this same length here of the chord, and if I can find that length, then I'll be able to double it, which will tell me the length of the entire chord. So again, try and get to right triangles because now we can use trig. So right now I'm trying to solve for this side length x down here. Side length x, and I'm given a side length and an angle measurement, so I can use trig. If this is the angle I'm looking for, I know that this is the opposite leg, this is the hypotenuse, so I know that sine uses the opposite leg and the hypotenuse, so I'm going to set up a trig ratio using sine in order to help me try and solve for that side length x. Here's the ratio that I've set up. Hopefully you came up with something very similar. And now it's my job to try and solve for x. I'm going to do that by multiplying both sides by 6 and getting x alone. So solving for x, I got 5.06 centimeters, and again, what I just found was this length right here, which in the bigger picture is this length, alright? and so we're not quite done because we wanted to find the length of the chord. The length of the chord is 2 times whatever I just found. So in order to find my answer, I'm going to take 5.06 and I'm going to multiply that by 2. In doing so, I'm going to end up getting 10.12. Okay, and that is going to be my answer, and I'm going to put some units on there. And I think the units I have in this problem might have said inches in the problem, but I'm going to write down centimeters anyways just to stay consistent. And so the length of that chord is 10.12 centimeters. All right, so the last thing before you can work on part B and C of this investigation, the book is referring to something called the perpendicular distance. That is this length right here. It's the distance from the center of the circle to the chord that we're talking about. And so this length, anytime you hear the perpendicular distance, this is what they are referring to. It goes from the center of the circle to the chord. And I think in the next problem it says the perpendicular distance of a chord, yada, yada, yada. And so that is what they're referring to. So in these problems, what you want to try and do is use the fact that we know that we have a perpendicular bisector that goes through the center of the chord. That's going to create 2 equal pieces of these chords. And then we can take all the given information in our picture to help us set up right triangles and solve for missing side lengths. I hope this helps. Yeah, I'll have all of the answers posted online as well, so as you work through, you can go back and check your work online, and we'll see you tomorrow.